Dear students, welcome to the most attractive session, moments, skewness and kurtosis. What is mean by moments? Moments are the quantitative measures. It helps us to describe the shape of a distribution. We have two types of moments. One is raw moments, the other one is central moments. We are going to see what is mean by raw moments and central moments and how to calculate these two. The notation for raw moments are mu r dash. We can put the value r equal to 1, 2, 3, etc. The raw moments basically help us to describe the properties like mean, spread, symmetry relative to 0. And the notation for central moment is simply mu r. It is very much helpful to find variance, skewness, kurtosis. We are going to see what is mean by skewness, kurtosis after few minutes. Now, for the discrete frequencies, let us see the formula for raw moments. The formula for raw moments in general is mu r dash, but for our problem point of view, we need mu1 dash, mu2 dash, mu3 dash and mu4 dash. We are going to write up to 4. So mu1 dash is equal to summation fx divided by capital N. We know that capital N is sum of frequencies. This is nothing but my mean. Then mu2 dash is summation fx square by capital N. So now you would have understand mu r dash is summation f x power r by capital N. We need up to 4. So the first 4 raw moments is given in the screen. Theoretically, we can write like this. You can just read it. The raw moments are calculated about the origin. That's why we write x minus 0 whole power r. But the central moments are calculated about the mean. So we are going to replace the 0 by x bar in this formulas. Then we get the central moment. Now we can see the formula for central moment. Mu1 is going to be summation f x minus x bar whole power 1 divided by n. This is always 0. Mu2 whole square, mu3 whole cube, mu4 whole power 4. This is for central moment, while the raw moments are mu1 dash summation fx by n, mu2 dash is summation fx square by capital N, etc. Now it is very important, we have to learn the relationship between the central moments and raw moments. Mu2 is equal to mu2 dash minus mu1 dash whole square. Similarly, mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 into mu1 dash whole cube. Similarly, mu4. So it is essential to remember this formula because in exams they can give mu1 dash, mu2 dash, mu3 dash and mu4 dash and they will tell you to find mu2, mu3, mu4. We know that mu1 is 0. This mu2 is nothing but my variance and mu3 helps us to find skewness and mu4 helps us to find kurtosis. Raw moments are the building blocks for the central moments. So now we write the central moments again. Mu1 is 0, mu2 is my variance, mu3 helps us to measure of skewness, mu4 helps us to measure for kurtosis. Next, in our syllabus, we have to find beta 1, beta 2. What is beta 1 and beta 2? These two measures describe the shape of the distribution using moments. Skewness. Skewness is a measure of the asymmetry of the probability distribution. Skewness helps us to tell how the distribution is non-symmetric. Beta 1. The formula for beta 1 is mu3 square divided by mu2 cube. So to find beta 1, you need these two parameters, mu3 and mu2. This beta 1 is always positive, sometimes 0 because mu3 square is going to be positive value. Mu2 is variance. Variance is always a positive value. So when you cube, you get always positive value. When beta 1 equal to 0, the distribution is symmetric. And now we have to check mu3. If mu3 is positive, then we can say it as positively skewed. If mu3 is negative, we say it as negatively skewed. Now you may have a confusion. What is mean by skewness? So let us see the pictorial representation. Yeah, this is the symmetric curve. If the curve is symmetric, then gamma 1 is equal to 0. This is the measure for skewness. Suppose if the curve is not symmetric, it is bended on the one side. So it may bend on the right or it may bend on the left. If it is towards right side, it is called as positively skewed, gamma 1 greater than 0. If it is towards the left side, then we say it is negatively skewed. In this case, gamma 1 is less than 0. So we can have the complete view. Positively skewed, negatively skewed. Now let us see beta 1. So we have three curves. Beta 1 is known as coefficient of skewness. Beta 1 equal to 0, then it is symmetric. If beta 1 is greater than 0, it is skewed. So if mu 3 is positive, we say positively skewed. If mu 3 is negative, it is going to be negatively skewed. The skewness is measured in gamma 1. Coefficient of skewness is measured in beta 1. Gamma 1 0, symmetric. If gamma 1 is greater than 0, positively skewed. Gamma 1 is less than 0, negatively skewed. Just now we see the formula. And now we have to write the relation between beta 1 and gamma 1. Beta 1 is equal to gamma 1 square. Now you can understand the visualization of skewness, and this is the formula. Next, let us see what is meant by kurtosis. Kurtosis is a measure of tailedness and peakness. It is mentioned, the coefficient of kurtosis is mentioned by the notation beta 2. To find beta 2, you need mu 4, mu 2. In the beginning of this session, we say raw moments are building blocks of central moments. If you know raw moments, you can find central moments. From the central moments, we are finding the shape. First, we find symmetric of the problem, that is skewness. Now, using mu 4 and mu 2, we are finding kurtosis. For a normal distribution, beta 2 equal to 3. Now, what happen if it is greater than 3, if it is less than 3? Let us see. If beta 2 greater than 3, it is called as leptokurtic. That means it has a sharp peak. If it is less than 3, we say it as platykurtic, that is flat peak. If it is equal to 3, it is just peak, it has normal tails, we say it as mesokurtic. If I say like this, you don't get idea. So let us go into the visualization. This is the normal curve, and kurtosis we use the notation gamma 2. Coefficient of kurtosis we use beta 2. If it is normal, gamma 2 equal to 0. If the curve is very sharp like this, then it is known as leptokurtic. So gamma 2 greater than 0. When the curve is not that much sharp, if it is much flattened, then it is known as platykurtic. Here gamma 2 less than 0. Let us see everything together. Mesokurtic, leptokurtic and platykurtic. Now you can understand this beta 2 helps us to find the peakedness and tailedness. So now we can write the contents. Coefficient of kurtosis beta 2. If it is 3, it is mesokurtic, that is blue one. If it is greater than 3, leptokurtic, less than 3, platykurtic. And this gamma 2 is known as excess kurtosis. If it is 0, mesokurtic, greater than 0, lepto, less than 0, platy. So now we write the formula for beta 2. We just see now. Beta 2 is equal to mu 4 divided by mu 2 square, and gamma 2 is equal to beta 2 minus 3. That's why we are getting beta is less than 3 or greater than 3 or equal to 3. Hope now you get the picturization about both beta 1 and beta 2 students. With this, we will go into the problem solving.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.